Welcome students, this is your 3.1, 3.2, day 2 practice. We did on this day continuous domain and range. And remember how it looked a little bit different from our discrete domain and range. Continuous domain and range, we put our left boundary over here, we had an X in the middle, we had less than symbols, and we had our right boundary over here, and sometimes these got lines under them, sometimes they didn't. And so this would be saying that the graph goes from a -3 on the left side all the way to a 9 on the right. We did our range the same way, except we went bottom to top. Remember we had $, the robot, to help us remember our order. Domain is left to right, range is bottom to top. So on a range we'd go, how low does the graph go? So it goes all the way down to -5, let's say. Y's go in the middle on range. Always start with less thans, and let's say it goes up to 10, and then sometimes these have lines and sometimes they don't, depending on these pictures. If it's an open circle, then that means it does not have a line under it. If it's a closed-in circle, that means it does have a line on them. So those are just some pictures that will help us throughout the year, this year. Okay, let's go ahead and get started in these. Alright, the first set of problems had to do with linear and nonlinear. So if we're looking at a picture, we're looking for things that are straight lines that are not vertical. Right? But if we're looking at a table, we have to look at the rate of change. So we go from here to here. 1 to 4 is up 3. 4 to 7 is up 3. 7 to 10 is up 3. So that looks good across the top because it is nice and consistent. Then we look across the bottom. 2 to 5 is 3. 5 to 6 is 1. And 6 to 10 is 4. And because this is not consistent across the top and the bottom, this would be non-linear. We're not trying to figure out what it looks like. We're just trying to figure out, is it a line or is it not a line? If your numbers are different at the top and bottom, then we talked about in class how you have to do y over x. So we would do 3 over 3, 1 over 3, and 4 over 3. We take all these numbers and we put them underneath as denominators. If those fractions are equal, then that's constant also. And so that would be linear. But in this fact, 3 over 3 is 1, 1 over 3 is not, and 4 over 3 is not. So this is non-linear no matter how you look at it. All right. To me, this type of problem was the most important one that we talked about yesterday. We talked about independent and dependent again. And so independent is our input, and that's always our x. Dependent is our output, and that's always our y. When we go back to the problem, it says the function y equals 3.5x plus 2.8 represents the cost y, so that's our cost, in dollars of a taxi ride for x miles. So x, so miles goes over here. Okay. I always think it's a good idea to look at the formula and try to figure out if you can figure some real-world meaning in it. We are getting in a taxi. When you get in a taxi, there's a flat fee. The flat fee to get in this taxi is $2.80. That is that y-intercept on the end of it. That's our flat fee. The 350 is your rate. That's your slope. So then it's 350 for each mile that you travel. Okay, and so just depending on how much experience you have with life, sometimes some of this part of the problem can be difficult. So if you've never ridden in a taxi, a lot of times you might not know that they have a flat fee and a mileage fee. But most of them do have two separate fees. Part B says you have enough money to travel at most 20 miles in the taxi. So miles are our x, so at most is 20. So we're starting our domain over here. We know that it's going all the way up to 20. So then we have to ask ourselves, well, what's the least amount of time we could travel in the, or miles we could travel in the taxi? And that, of course, is 0. If we choose to not get in the taxi, we could go 0 miles. We always start with less thans. And then we could go 0, so we have to put a line under it, and we could go 20, so we have to put a line under that. It just means that we're including 0 and we're including 20. So that is our domain. Now we got to figure out our range. Okay? And so our range is going to have y's and less thans. And the first thing we have to figure out is, what is the minimum number? If we go 0 miles, how much is it going to cost us? Okay? What I like to do at that point is go to the table and go to y equals and type in my expression, which is 3.5x plus 2.8. And if you just go to the table for your x's and y's and look to see what goes with 0, you'll find that it's 2.8. Okay, so this is 2.8. And I gave you a picture of the table over here, but I didn't include the 0 part of it, but it is 2.8. That's where it started. Okay? Then we scrolled all the way down to 20 right here to figure out that the maximum cost, if we go all 20 miles, is $72.80. If we go 0, it is going to cost 2.80. If we go 20, it is going to cost 72.80, so we have to include those numbers in there. So that is the answer to it, $72.80 to go all 20 miles. Okay. All right, I'm going to use red to do my domain, so I draw my line down the far left-hand side. That intersects with that number. I draw it down the right-hand side. That intersects with that number. So my domain starts at 0 and goes to 6. Domain is X. They have black dots, so I put lines under them. And so that's the domain. Okay? I could very easily do the range, and I think it's important to be able to do that as well. So we go bottom. I'll go across the bottom. That's the number that it intersects with. And across the top, that's the number that it intersects with. So bottom is 20. To the top is 60. Range is Y. We always start with less than. Black dot on the 20. Black dot on the 60. So that's your range for that problem. Alright, this one asks for range, so I'm going to start with the bottom here. That's your bottom, and that is your top. Okay. There's no number right there, so we'd have to count that out. That's -1, that's -2, and that's 1, that's +2. So it goes from -2 on the bottom to +2 on top. Range is Y. We always start with less thans. This does not have any black dots, and so we have to ask ourselves, does the circle hit that line? And in fact it does. Does the circle hit that line? And it does. Okay. We could very easily do domain on this one as well. Domain starts over here, left, and goes to the right. So that's -2, and that's +2. Domain is X. Start with less thans. Again, it does touch on both sides, so we have to put the equal to parts. Okay. We're going to continue to talk a little bit about this domain and range next class period, just because I feel like we did not get enough of it covered.